Hello everyone, this is the answering session for exam 2 review questions. Exam 2 covers chapters 5 through 8. Okay, let's move to the questions. First question: if two events are complementary, then we know that what? The answer is A. The sum of the probability is 1. Because that's the definition. That's from the definition of complementary events. Because if event A is complementary of event B, that means that's event A is something that's happening, and event B is everything else except for that something's happening, or it's not happening. So the two events together, make up everything, all the possibilities. So their probabilities together, or added together, or sum, is 1. So the answer B, the joint probability of 2 is 1. That's definitely not true, because they don't, the joint probability is normally not 1. It's part of is the event that both A and B are occurring. Right? The intersection has a non-zero probability. That's not necessarily true, because they may not have intersections. They're independent events. They have to be independent events when we talk about this. But that's just being independent itself does not mean that they are complementary events. Okay. For second question, find the probability that either A or B occurs. If the chance of A occurring is 0.5, the chances of B occurring is 0.3, and events A and B are independent. If that is the case, we know how do you calculate the probability that either A or B occurs. What do we mean by either A or B occurs? Right? Either A or B occurs means that's the union of the events A and B. Okay? The union of event A and B is what? That is from the book, from the definition, we know the union of events A and B is probability P of A, PA plus PB minus intersection, right? PA in this case is 0.5, PB is 0.3. What is intersection of A and B? Intersection of A and B is 0.5 times 0.3, that is 0.15. So the probability that either A or B happens should be PA plus 0.5 plus PB plus 0.3 minus intersection. 0.5 plus 0.3 minus 0.15, that is 0.8 minus 0.15. That will give you 0.65. Therefore, C is correct answer. Okay. Next question. Given this contingency table shown here, find PV. What is PV? That's probability of V. Right? In this table here, contingency table here, this basically says, from people from 3 counties, Macomb, Oakland, and Wayne counties. And these are the numbers of people who are using either Sprint or AT&T or Verizon as their cell phone service provider, right? There are, say, for example, there are 17 people from Macomb County using Sprint, 25 from Macomb County using AT&T, and 8 using Verizon, and so on and so forth. The total from Macomb County, we have 850 people, Oakland 70, Wayne and 80 in the sample, and the total people from 3 counties using Sprint is 60, using AT&T is 100, using Verizon is 40. So the grand total is 200 people surveyed. Now PV is what? PV is you surveyed from your sample. Now what is the chance of someone is from V or using Verizon? Now we know that how many people are using Verizon? 40, right? 40 out of total 200 people. 40 divided by 200, what do you get? That's 0.20. Therefore, A is correct answer. Okay. next question. Given the conditions table shown here, right, the same table basically, let's find the P, A, this symbol, and M. What does symbol mean? If you recall, that's the union. So what's the probability of the union of event A and M? Now, what is event A? A is that someone's using AT&T. M is that someone from Macomb County. Now, that is what is the probability of the union of that? Meaning the person is what? Is using AT&T and from Macomb County. And how many people are there? Right? And we know that the union of A and M equals what? Union, okay, I have the equation here. I use this actually U to denote this term, this the symbol of a union. We know that is PA plus PB minus intersection, right? Sorry about I have to use this because I can't type those math symbols on my Word. Okay, so PA in this case is what? What's probability of PA? That is people using AT&T, right? That's PA is 100 out of 200 people. So therefore, that's this right here. And PB is what? PB in this case, B is M actually, right? M is Macomb County. How many people are from Macomb County? We have 50 people, 50 out of 200. So therefore, PB, this term here, equals 50 out of over 200. Okay. And what is the intersection of A and M? Intersection of A and M, right? Intersection of A and B, I use B here, it should be A and M. That is people from AT&T, using AT&T from Macomb County, the 25 of them. So the 25 out of 200. Right? If you add, you do calculation math here, you said this is 100, or the common denominator is 200. You have 150, 25. So 100 plus 50 is 150, minus 25 is 125. 125 divided by 200, you get 0.625. Therefore, C is answer, the correct answer. Okay, move on. The discrete random variable X is the number of passengers waiting at the bus stop. The table shows the probability distribution of X, the number of passengers. What is the expected value for this distribution? Now, how do we calculate the expected value? Right? Expected value is xi, each individual x number here, and multiplied by its probability, and then add it up. Right? Basically, this number times this, and it should be written as 0.2 is 0.2, this times 0.4, this times 0.3, this times 0.1, and add them up. And this term we know is 0.2 is 0. The 1 times 0.4 is 0.4. 2 times 0.3 is 0.6. 3 times 0.1 is 0.3. So this is 0.4, 0.6, 0.3. You add them together, it's 1.3. So therefore, B is correct answer. Okay. Second one, next one. The binomial distribution describes the number of what? This, you basically just have to go back to the definition. Is a success in Bernoulli distribution. Okay. That's the answer, correct answer. It's not the trial to obtain the first success. That's not true. Okay. It's not a trial to obtain n successes. That's not true either. Right? In the Bernoulli, it's this number of successes. Right? It's not success or failure in Bernoulli. So this is basically straight from the definition. Next one. A random variable X is distributed binomially. Now, so we know it's then binomially. Yeah. With n of 8 pi of proportion is 0.7. The standard deviation variable is approximately what? Right. Now, what's the definition of this? What's the equation to use that? That the standard deviation S should equal the square root n pi times 1 minus pi. Okay, what's n pi minus times 1 minus pi? We know n is 8, pi is 0.7. 1 minus pi, 1 minus 7 will be 0.3. So 8 times 0.7 times 0.3 will give you 1.68. 1.68, you take a square root of that, it should give you 1.296. Okay. Next question. On average, an IRS auditor discovers 4.7 fraudulent income tax returns per day. That's pretty bad. On a randomly chosen day, what is the probability that she discovers fewer than 2? First, what kind of distribution is this? If you remember that you can consider this fraudulent income tax returns as arriving at the IRS office, per day, every day, right? So if it's on a given day, a given time frame, the arrival on a given in a given time frame, we know that that follows a Poisson distribution. A Poisson distribution, there's only one parameter, that's a lambda. Lambda is the mean arrival per unit of time. This is exactly what it is. The mean arrival, the average fraudulent tax return coming in per given day, just per day, is 4.7. Right? Now, how do you find the probability that she discovers fewer than 2? What do you mean by fewer than 2? Think about fewer than 2. If you discovers 0 bad return, fraudulent return, that's fewer than 2. If she recovers 1, that's fewer than 2, right? And then if she discovers 2, that's not fewer than 2. So basically, that's the probability that she discovers 0 fraudulent return or 1 fraudulent return, right? If you go to your page 561 of your book, look at the Poisson distribution. Under lambda 4.7, you find that the probability of getting 0 bad return is 0.0091, and probability of getting 1 is 0.0427. Okay, you add the two together is 0.0518. Now that is probability of getting either 0 or 1 bad return, and that is indeed fewer than 2. Okay, so therefore the correct answer is A, 0.0518. Okay, let's move on. The following relationship always holds true for events A and B in the sample space. Which one is holding true? This one is. Why is that the case? Right. If you look at the definition of we see here, there's what is this here? This right here. That's the conditional probability of A given B happening. We know conditional probability of A given B is this, the intersection over PB. If we move the PB over, therefore the conditional probability of A given B times PB will be the intersection. So this one is holding true. The other two are not. Okay. This one here. How many ways can we choose 3 items at random without replacement from 5 items? A, B, C, D, E. If the order of selected item is not important. Now the key here, the key term is that is not, the order is not important. If order is not important, we know it's a combination issue, right? It's a combination. If it's combination, now how many ways can we choose 3 items from 5? That's strict from the definition of combination. We know NCR combination is n factorial divided by r factorial times 1 minus r factorial. In other words, this is n is 5, r is 3, right? So it's 5 factorial divided by 3 factorial times 2 factorial. 5 factorial equals 5 times 4 times 3 times 2 times 1. And 3 factorial is 3 times 2 times 1. 2 factorial is 2 times 1. Therefore, you carry out the calculation. I want to do this yourself. You should see that the answer is C, 10. Okay, there's 10 different ways you can choose 3 items from 5. This one is also straight from the definition, P4P2. That is, you choose the 2 items from total of 4. That the order is important, because that's permutation. You carry out that should be 4 divided by that's n factorial divided by n minus r factorial, or 4 factorial over 2 factorial. That is 12. So D is correct answer. Okay. This question here, which is not a discrete random variable, right? The number of births in the hospital on a given day, that is a discrete, because you can only have maybe 200 babies per day in a given hospital, or maybe 5 babies. You cannot have 1.5 babies, right? So that is not the answer, right? The number of 5s obtained in 4 rows of a die, and that's also countable. So therefore, it is discrete. So it's not a correct answer. The hourly earnings of a call center employee in Boston, and that could be that is a discrete, because the hourly earning for this person could be, $10.50 an hour, etc. The number of applicants applying for a job, this is we can have like 1.2 persons. It has to be a whole number. Therefore, the correct answer is C. Okay. Next one. Which distribution is most nearly appropriate to describe the number of fatalities in Wisconsin per year due to poisonous snake bites? This is kind of like, this is unfortunate, of course. You don't want to be bitten by a poisonous snake. But what kind of distribution is it? Is it binomial? You cannot say that, right? We know what the binomial distribution is. Binomial is a Bernoulli distribution repeated many times. Is it uniform, or it better not be uniform? Uniform means that the probabilities are the same for everyone. So Poisson is the best, and this is the answer, because you can kind of like imagine that the poisonous snakes kind of arrival at a given time. So this is how many people get bitten. So arrival, kill, bite people, during the year. So Poisson distribution is probably the best. It is best to describe this kind of event. Okay. Next question. A charity raffle prize is $1,000. The charity sells 4,000 raffle tickets. One winner will be selected at random. At what ticket price would the ticket buyer expect to break even? So this is the expected value calculation, right? So what do you expect if you buy a ticket, a raffle ticket? Okay? Let's see. You could buy. What's your chance of getting getting the raffle prize of $1,000? They sold 4,000 tickets, right? So your expected value will be, you could be getting $1,000 right here, $1,000, but your chance is 1 out of 4,000, right? That's a pretty small chance. What is the chance that you get nothing? You get $0. So your chance of getting $0 is 3,999 out of 4,000. That's a pretty big chance, right? So if you carry out this calculation, this is 0, right? This is 1,000 times 1 over 4,000 is 0.25, so or it's 25 cents. That's your expected value. And let's move on to the next one. Given the conditions table shown here, find PA2, right? PA2, where's PA2? Right here, PA2. That's the. Now, what is how do you do that? How many A2? That's the probability of finding finding sample from the probability find a member from the sample. That is A2, right? So the PA2 this should be 86. A2, the total of A2 is 86 right here, out of total of 467. So PA2 should be 86 divided by 467, you get 0.1841. You can round up. There's a rounding error here. So for A, 0.1842, that's the correct answer. Okay. Next question. Given the contingency table shown here, find the A3, this, and B2. What's this? This is the intersection of A3 and B2. A3 is here, B2 is here. The intersection is right here, 44, right? So the probability of the intersection is 44 divided by total. So 44 divided by total, you get 0.0942. Therefore, C is the correct answer. Okay. Next question here. Given the conditions table shown here, does the decision to retire appear independent of the employee type? The survey question asked was, do you plan on retiring or keep working when you turn 65? Of the people or the employees asked, there are some managers, there are some line workers. We basically want to see if your decision to retire or not to retire, to keep working, depends on the type of jobs you have. Are you a manager or a worker? Right. These are the answers. 13 of the managers said they're going to retire. 18 they said they will continue to work. 39 of line workers say they would retire, and 54 said they would not. They would continue to work. Right. So the question is, does the decision to retire appear independent of employee type? What we can do is we find what is the probability of someone wanting to retire? The PR. PR is 52 divided by 124, because there are 52 people who chose to retire, regardless of the type of the work they have. 52, right? And now total 124 people. 52 over 124, you get 0.41935. So for given any person whose chance of choosing to retire is 41.9%. Okay. Now let's see what's the probability that someone who is a manager also chooses to retire. That's R given M, or the conditional probability of R given M. That if someone is manager, what is his or her probability of choosing to retire? And how many of them are choosing to retire? We know the 13 managers who chose to retire out of total of 31. So 13 over 31 is 0.41935. These two are the same, meaning for anyone whose chance of choosing to retire is 41.9%. And for managers, their chance of choosing to retire is also 41.93. Therefore, we say, the decision to retire appear to be independent of the employee type. Yes. Therefore, A right here is correct answer. Okay. And for the next question. A machine dispenses water into a glass, assuming the amount of water dispensed follows a continuous uniform distribution. Here is the key, continuous uniform distribution, from 10 ounces to 16 ounces. What is the probability that 13 or more ounces will be dispensed in a given glass? Now, what are we calculating here? Basically, we want to see if what is the probability that 13 or more ounces. Basically, the X is larger than or smaller than 15, or equal to 13. So if X, you use equation X minus A over B minus A. X minus A is 13 times the. Let me see. 13 times 10, because A is 10, B is 16, over B minus A, that's 16 minus 10, that's 3 over 6, you get 0.5. Okay. Therefore, C is the correct answer. Okay. Next one. In Melanie's styling salon, the time to complete a simple haircut is normally distributed with a mean of 25 minutes and a standard deviation of 4 minutes. What percent of customers require less than 32 minutes for a simple haircut? Right. Okay. In this case, we know the how do we calculate this? We know this is follow a normal distribution. It's normally distributed. For normal distribution, we find the z-score first, right? For z-score of less than 32, you can 32 minus the mean of 25 divided by the standard deviation 4. We calculate that z-score. We find that the 32 minus 25 is 7. 7 over 4 is 1.75. 1.75, what do? You go to page 565. Page 565 of your book. You look at the table over there, you find the probability to be 0.9599. Okay, that's what you should find, right? And therefore, the probability here is 95.99%, or A is the correct answer. Okay. Last question. To estimate the average annual expenses of students on books and class materials, a sample of size 36 is taken. The mean is $850 and standard deviation is $54. A 99% confidence interval for the population mean is what? This you go back to the definition of the confidence interval, which is z-score times the for 99% confidence interval, z is 2.576 times 54. That's the standard deviation over the square root of 36. That is number. That is the standard deviation. You carry out this equation calculation, you get 23.184, and then plus or minus the mean of $850, and this plus $850, you get 874.51. Actually, sorry, this should be 873.18. Okay, yeah, this is wrong answer. The C is correct answer. 23 plus 850, you get 873.184. So that's this one right here. 850 minus that, you get 826.82. So that's your confidence interval at a 99% confidence level. But this, expense, this means estimation. So that the correct answer, make sure that the correct answer is C, not D, right? This is how you calculate. You carry out the calculation. Okay, I think that's the conclusion of the answers to all the review questions for exam 2 that covers chapters 5 through 8. Good luck with your test.